China launched 400 drones off the coast of Okinawa. Beijing spent $40 million on that attack. Japan fired back with light. Each shot cost $1. The entire swarm was wreckage in under 3 minutes. The U.S. Navy's best warship carries 96 interceptor missiles. A 400 drone swarm burns through every single one and keeps coming. Every Pentagon simulation ended the same way. The carrier dies. The defender always runs dry. Japan didn't run dry. Japan doesn't have a magazine. Here's exactly how. In March 2026, the Japan Maritime Self-Defense Force ran the most consequential live-fire exercise in its modern history. Open water off Okinawa. 1 Aegis destroyer. 400 simulated drone targets launched in simultaneous coordinated attack formations. The laser didn't miss once. The engineer behind that result is Hiroshi Tanaka, lead systems architect at Mitsubishi Electric's Advanced Defense Division. For 6 years, his team hunted one specific failure point: thermal runaway. Every previous high-energy laser system in the world hits the same wall. Fire-sustained bursts accumulate catastrophic heat in the core emitter. Force shutdown. The weapon designed to defend Japan's fleet was defeating itself in under 30 seconds of continuous fire. Tanaka's solution was modular solid-state emitter architecture. Distribute thermal load across a parallel network of emitter arrays instead of concentrating it at a single beam source. No single failure point, no thermal accumulation. The result, a 100 kilowatt system that fires indefinitely with zero cooldown requirement. One more number nobody is reporting. The targeting computer reassigns to the next drone in 0.8 milliseconds. A human blink takes 400 milliseconds. This system locks, fires, destroys, and moves to the next target 500 times before the tactical officer on the bridge finishes a single blink. The same directed energy doctrine behind the F-47 program just went fully naval. Japan pulled the trigger first. Now run the math. The U.S. Navy's Phalanx close-in weapon system, the last line of defense on every American surface combatant, fires at $30 per round. At full operational rate, and sustained engagement costs $135,000 every 60 seconds. It runs dry in under 4 minutes of continuous fire. Against a 400 drone swarm, it is a finite resource racing against an infinite problem. Japan's laser fires at $1 per kill. The system draws roughly the same electricity per hour as running 3 commercial refrigerators. One Chinese CH-901 loitering munition costs $100,000. China committed 10 simultaneous 40-unit swarm packages in its most recent Taiwan Strait exercise. $40 million in a single engagement window. Japan neutralizes that entire commitment for $40 in electricity, the number that ends the strategic debate permanently. China fields an estimated 300,000 loitering munitions across its military branches. $30 billion of hardware. The centerpiece of Beijing's Pacific dominance strategy for 15 years. Japan can neutralize every single unit for $300,000 in electricity costs. China didn't just lose the swarm war. They spent 15 years financing Japan's proof of concept. At 100 kilowatts, the beam delivers energy equivalent to focusing 300 commercial blowtorches onto a surface the size of a postage stamp. But the comparison undersells the physics. A blowtorch distributes heat. This beam doesn't distribute anything. It deposits energy at a single coherent point faster than the material can thermally conduct it away. Aluminum, the primary structural material in China's drone fleet, melts at 660 degrees Celsius. The Mitsubishi beam hits triple that threshold in 0.3 seconds. Carbon fiber composite doesn't melt. It delaminate fractures. The resin matrix vaporizes before the fiber structure can respond. The airframe doesn't burn. It disintegrates at the molecular bonding level. At 5 kilometers range, the beam maintains a focal diameter of 10 centimeters. That is tighter than a dinner plate at a distance of 5 football fields. Standard laser systems bloat to 3 meters at that range, scattering energy uselessly across the airframe surface. Mitsubishi's adaptive optics system compensates for atmospheric turbulence in real time, maintaining that 10-centimeter kill point regardless of sea state conditions or humidity. The targeting AI processes atmospheric refraction data, individual drone velocity signatures, and full swarm formation geometry across all 400 targets simultaneously. It prioritizes by proximity, convergence angle, and threat tier in milliseconds. No human fire command required. And here's the part that makes Beijing's engineers lose sleep at night. There is no countermaneuver that works against coherent light. Speed is irrelevant. A drone at Mach 1 is still 881,000 times slower than the beam. The geometry is brutal. At 5 kilometers, the beam reaches its target in 0.000017 seconds. A drone traveling at maximum evasive velocity moves less than 1 millimeter in that window. Chaff is irrelevant. No radar signal to confuse. Electronic jamming is irrelevant. No guidance frequency to disrupt. Heat-resistant coatings are irrelevant. The energy density exceeds the thermal tolerance of every known material that can be economically mass-produced at drone scale. China's entire swarm doctrine rests on one assumption. Defenders run out of interceptors before attackers run out of drones. Mitsubishi deleted that assumption from every wargame running in the Pacific. But here's the question nobody is asking. Can China engineer a drone that physically survives a direct sustained laser hit at this energy density? Drop your answer in the comments. The best theory becomes our next full video. Look at the map. The first island chain, Japan, Okinawa, Taiwan, the Philippines, is the containment barrier defining China's entire Pacific expansion doctrine. For 15 years, Beijing's swarm arsenal had one strategic purpose: punch holes through that chain, exhaust the defenders, flood the zone, make the math impossible to win. Japan operates 37 Aegis-capable destroyers. Every single one is now receiving the Mitsubishi system. 37 ships. 37 platforms with effectively infinite magazines positioned across the exact maritime choke points China must control to project naval power into the open Pacific. Beijing's countermove is already visible in its procurement data. In Q1 2026, China quietly redirected 30% of its loitering munition production budget toward hypersonic glide vehicle acceleration. The calculation is clear. A laser at the speed of light still faces a reaction window problem against a Mach 15 vehicle descending through atmospheric plasma. That is the next race. But the swarm race is over. Closed. The chapter Beijing spent 15 years and $30 billion writing. Japan ended it with an electricity bill. The 100 kilowatt system is operational today. The roadmap doesn't stop here. The 300 kilowatt variant is in advanced testing at Japan's Defense Advanced Research Institute in Yokohama. At that power threshold, threat classification expands entirely. 300 kilowatts structurally destroys an incoming cruise missile at terminal phase. It generates sufficient energy to permanently disable low-orbit reconnaissance satellites at 500 kilometers altitude. No kinetic contact required. It delivers enough focused heat during atmospheric descent to compromise hypersonic glide vehicle guidance systems in the exact 40-second vulnerability window where those weapons are most exposed. The 2028 deadline is not a suggestion. It is the exact date the Pentagon designated as the Pacific vulnerability window, when China's conventional naval capability peaks before U.S. sixth-generation systems fully come online. Japan's deployment timeline is calibrated specifically to hold that window shut. The Allied response was immediate. South Korea accelerated its directed energy program by 2 full years within weeks of the March exercise results. Australia opened joint development negotiations with Mitsubishi within 72 hours of declassification. The UK Royal Navy formally designated the Mitsubishi architecture as its reference standard for the entire 2030 fleet modernization program. Japan didn't just build a weapon. Every major fleet on Earth is now measuring its future against what one destroyer proved off Okinawa. 6 years ago, the swarm drone was the problem nobody could solve. Every simulation, every classified Pacific scenario. Same result. The defender runs dry. China's strategy was mathematically airtight. $30 billion of hardware built around one assumption, that defenders always run out first. Mitsubishi retired that assumption. Japan ended China's primary Pacific doctrine with electricity costs measured in cents per kill. Subscribe and see you in the next video.